Number 24, for what values of x does the power series the sky converge absolutely, conditionally? This is an interesting problem in that if you've been following along in this series, this is asking about interval of convergence actually, but it's asking it a little differently. It doesn't just ask for what values of x does this power series converge. That's what we've been doing in the other problems. This time it's asking for what values of x does it absolutely converge and conditionally converge. So are we going to get intimidated by this? Hopefully not. This is how we think through it. Recall the ratio test. Actually, I don't really say this every time, but this is actually what happens. When we do the ratio test, it actually determines absolute convergence. If something's absolutely convergent, then it's convergent. That's why I usually just say it's convergent instead of absolutely convergent. But you have to remember that the ratio test actually determines absolute convergence. So does the root test, actually. But let's focus on the ratio test here. So we don't do anything different, actually. We just go through the motions of the ratio test. Limit as n goes to infinity, a sub n plus 1 divided by a sub n. We go through the math. I'm going to skip over that. Hopefully you're competent in that by now. You can definitely pause the video to check out the steps I did here. We set it less than 1. One more time. The ratio test says if this result of the limit is less than 1, it's absolutely convergent. So we're going to answer the first part of this question directly, just by this ratio test that we've been doing the whole time. Okay, so we start solving for x in this inequality. After that, we get -1 less than x less than 3. So therefore, for x is between -1 and 3, the series absolutely converges. Okay, but we're not done though. So remember in the other problems, to find interval of convergence, we check the endpoints. And if you remember, sometimes both the endpoints converge. Sometimes both the endpoints diverge. Sometimes one of the endpoints converges. One of the endpoints diverges. Hopefully this is piecing together now in your mind. If both of the endpoints converge, then we actually have absolute convergence there as well. If one converges, one diverges, maybe we have conditional convergence. Okay, if you remember, conditional convergence means if the original series converges, but the absolute valued version diverges, it's conditional convergence. Okay, and obviously, if both diverge, neither is it absolutely convergent nor conditionally convergent because they're divergent. Okay, so that's why we're going to check the endpoints now to see if we include them in the absolute convergence interval, or do we put them in the conditionally convergent interval, or we don't put it in any of the two. Okay. So I said here, we have to check the endpoints manually. So same as before for finding the interval convergence. We plug in x is -1 into the original guy. We would get this over here. Does this series converge? Does it diverge? It diverges. Okay, this is another key point here. If your professor or grader is picky, you can't use the alternating series test to conclude that this series diverges. The alternating series test only proves something converges. It doesn't prove something diverges. Okay, so if you had said that, oh, because the limit as n goes to infinity of this guy is not 0 by the alternating series test, this series diverges, you probably get it wrong. I would mark it wrong if I were the grader. So we got to use the appropriate test, which is to test for divergence. Precisely because the limit does not exist and it's not equal to 0, this actually oscillates between -½ and +½ the series diverges by the test for divergence. Okay. Other endpoint, x is equal to 3. We plug in x is 3, we would get this. This, if we take the limit, it's not 0 as n goes to infinity. Therefore, it diverges by the test for divergence. So the endpoints are not even convergent, so we don't even have to include them in either the absolute convergence or the conditional convergence. So that's what it says. Since both endpoints diverge, the interval of absolute convergence doesn't change from before. And I forgot to state this. Maybe since I'm on the Word doc version, the series never conditionally convergence. Let me put it here. Okay. Okay, so we answered both questions now. The interval for the values of x in which the series absolutely converges is between -1 and 3, not including the endpoints, and it never conditionally converges. Okay, so I have two comments now. Comment number one. It's not a coincidence that one series was n+1 over 2n+1. This was endpoint x is 3, and the other one was just a changing sign. It's not a coincidence. And hopefully from doing enough problems on interval of convergence, you recognize this pattern. Okay? Hopefully you're not just blindly going through the motions and not thinking about the problems and trying to realize possible patterns to help speed you up. Okay, so that's comment number one. Number two, so this is just for explanation purpose, okay? If, for example, the series converged at x is -1, but diverged at x is 3, okay? So this was the series that x is -1. This is the series that x is 3, right? Pretend it converges, okay? Pretend this one converges by the alternating series test. Pretend, okay? The absolute valid version, if it diverges, then we say this guy is conditionally convergent. So that's why at that endpoint x is -1, it would be conditionally convergent. That's the only value. Okay, we don't say that it conditionally conditionally converges at x is 3 because the absolute valid version of this is itself. And they both diverge. Anyway, so that's why. Okay. That's just a technicality to explain the possibility of conditional convergence. Okay. Hopefully this was helpful. Again, this is really not different than all the other interval of convergence problems we've been doing. If you've been following along the series, it just asked it in a little different way. And we just had to remember the concept that the ratio test actually determines absolute convergence. And then we had to check the endpoints manually because the ratio test is inconclusive there. And precisely at those endpoints, sometimes it converges, sometimes it diverges. That's going to determine if it conditionally converges, most likely. Or if they both converge, then we lump it into the absolute convergence. Okay, that's it for this video. Hopefully, again, my explanations were helpful. If it was helpful in any way, please give this video a like and or subscribe to the channel to show your support. And hopefully I see you in another video as well. Bye.